Okay, hi everybody, welcome back to step 4 of the AIR module calculations with the VALESOR digital tool to calculate economic values of pollution. Again, as a reminder, we are now done with the input data step and we will now move on to the output step. Here you have the option, quite many user options, to select which type of output and which type of assessment you want. Again, we have our countries here to the bottom left. Above that, you can select which output you want to look at. The info green dots with an eye on them, they gives you certain information about the choices. You can select calculations of environmental burden of disease or health impact assessment. And what's the difference? Well, the environmental burden of disease gives you absolute numbers for health impacts for each scenario, but the health impact assessments gives you relative numbers between the baseline and the other scenario. You can look at your health outcomes as individual health outcomes or as quality adjusted life years. In other words, the health outcomes are associated with effects on the quality of life, and that has been studied, and you can aggregate the results as quality adjusted life years instead of looking at the health outcomes. We also have the values chosen of the exposure response function. Do you want to do calculations of the central estimate or on the high effect or the low effect? You make that choice here. And of course, you can look at the output table. Do you want the countries aggregated or the countries shown separately? In addition, you can also choose which mortality valuation metric you are considering most suitable for your analysis. Is it to study premature mortality as numbers of lives lost or years of life lost, YOL? And you can study whether you want to use you can choose whether you want to use counterfactuals or not. Often when you make a choice, let's click this button here, you can change the calculations slightly. And if you choose health impact assessment instead of environmental burden of disease, the calculations below will change. Furthermore, you are able to choose which type of health outcomes you want to look at. First choice, do you want to look at all causes for premature mortality, or do you want to look at specific causes of premature mortality? For all cause, click the left box. For cause specific, click the right box. We will continue with all cause in this case. You can consider long-term effects and or short-term impacts, and you choose that by clicking on the boxes. In this analysis, we will look at long-term effects. You can also choose whether you want to include only the most reliable studies or not the most reliable, but the studies for which we have a best explanation of causality between pollution and health effects. Some effects are better studied than others, and those are called core in the VALESOR tool. The non-core are the ones where the burden of proof is not yet as solid as it is for the other group. So do you want to include the core and the non-core or only the core? And in this case, we will choose both. What impact type do we want to study? Only mortality or morbidity as well? We would like to study morbidity as well, so we check that box. But we would not like to include the non-core, so we unclick that box. And the effect of your choices here in the health outcome filter you can see on the table to the right, where you can see the choice of adding or not adding non-core effects will be shown here, that it will not include the incidence of dementia caused by pollution or the incidence of diabetes related to pollution. If we would have included the non-cores, you can see here that they are then included. All right, so now we made that choice. So we will look at an environmental burden of disease. We will look at premature deaths. We will use counterfactuals and for the centrals. So let's click complete and it starts to calculate a bit. It will always calculate in the background, but to make sure. So here you have the solution from the model. You will see the results presented per pollutant, outcome, and exposure window, whether it's core or not, but all we have is core here. What unit you have, and alternative 2030, baseline 2015, baseline 2020, and baseline 2030 scenarios. Now notice that I'm a bit confused by the unit because it said deaths or cases, but this is an economic valuation tool, and well, yeah, I forgot to click the right value. So now that I've calculated the results here with the complete button, the show filters disappears, but click on show filters and realize that you can actually choose the type of output. So instead of health impacts, I want to have the economic valuation results. The model recalculates quickly, and now scrolling down, yep, here we have the values as economic values. The units are now Euro 2020 in all cases. So you can see here that the costs for long-term natural all-cause mortality from PM 2.5 for the both of the countries is 32 billion euros in the year 2015, going down to 22 in the baseline in 2020. So those are historical years. If our guesstimate is correct for 2030, it will go down to 14 billion, but it can go down if our guesstimate is correct. With another microgram of emission reduction, it could go down to 9.6 billion euros. And then you have results here for all of them. And we can split, and we do show you the splits of costs between the scenarios for healthcare sector expenditures, productivity losses, but also disutility, so the ill-being of being exposed to pollution, as well as the mortality. So those are split in those 4 categories. The columns can show us the costs in Euro 2020 per health effect, and if you roam above the columns, you can see which part of the column that is which type of health effect. And as you see here, mortality, of course, dominates. You can see damage per impact type instead, looking at mortality or morbidity. And again, you can see that this is mortality, and it usually dominates. Another illustration is which type of cost you are looking at. So you have the disutility associated with morbidity and healthcare sector costs on top of that. Now, let's say that this is not exactly what I wanted. I want to do a different type of analysis. I still want economic values, but I want to look at the health impact assessment instead. And I do not approve of the counterfactuals that we have. What is the counterfactual? So it's basically a default counterfactual concentration recommended by WHO in these type of analysis. So I remove this. I still want to look at individual health outcomes, but I do prefer the analysis to be made on value of statistical life. See if something happens with the results. The health impact assessment, remember that this is the one where we should look at the relative costs between the baseline and our other scenario. Still the same amount of health effects, and all of a sudden the results are much more, they are shorter basically. We only have one column with the results, and it's the alternative 2030, because it was only for the alternative 2030 that we had a difference between baseline and the alternative. But then again, the results will show you for only 1 year the damage per health outcome, the economic value, the damage per impact type, the damage per cost type, again, the same. So with that, we have looked around at different choices we can make in terms of output, what type of assessment we want to do. We have enabled choices for which type of health outcomes we want to look at. And we do have abilities to choose or not choose here. This is these boxes are chosen by the health outcome filters, and we have shown you the type of results that you can get out as tables and as figures. And with that, the fourth step of the calculation is done. So we will now choose to save the project, and the project is saved manually, and then we will export a JSON file. In the next video, we will look a bit about the simplicity in how to work with JSON files. So click on Export JSON, and it asks just to save project alternative, and then we save. And the next time we look at this study here with the VALESOR Air digital tool, we will start from the JSON file. And thank you very much for your attention, and I hope this was instructive.